Welcome to the lesson on the chain rule. So we finished covering the basic rule of differentiation, which is called the power rule. And just in case you've forgotten, power rule refers to if y equals x to the n, then y prime, y dash is equal to nx to the n minus 1. So if you had, let's start with something simple, like x to the 5, and you try to, if you had y equals x to the 5, then y prime, y dash, I call it y dash, I'm used to calling it y dash, so just bear with me. Y dash, you bring the power down, right, x, you decrease the power by 1. That's the basic rule of, that's one of the basic rules, right? It's called the power rule. Anyway, moving on. Today we are starting the second rule of differentiation, and this rule applies when you have a function inside another function. And for example, we know that y equals u to the 4 is a function. Y equals u to the 4 is a function. But what if, let's say u is x squared plus 3x. And so if you sub it in, you'll get that. Now notice, you have inside that function, inside where the u is, I've put that in. I've put that in place of u, and so you have x squared plus 3x, all to the power of 4, Okay, so just examine and pause the video, make sure you understand. It's very important that you understand where I'm coming from. If you don't understand, you won't be able to apply the rule. Okay, you have a function inside another function. So we have a function of a function. Chain rule is also known as function of a function rule. Anyways, you have a function inside another function. So you have one function inside another function. Now let's see what happens. So if you have y equals x squared plus 3x all to the power of 4, then we can think of this as y equals u to the 4, and u is x squared plus 3x. This is kind of what I just explained in the previous slide, right? We just subbed this into there, and we had that. And we're just doing it in reverse. If you have that, we can think of this as being u all to the power of 4. We're saying x squared plus 3x, let x squared plus 3x equal to u. And then you have this y equals to u, where u is equal to x squared plus 3x. Hope you're following along. Let's move on. So when you have a function inside another function, we apply the chain rule. And the chain rule states, if y equals g of u, it's a function of u, and u is a function of x, then you have this complicated looking thing, which basically is saying, if you differentiate y, dy means to differentiate y with respect to x, you need to differentiate y with respect to u, then multiply by the derivative of u with respect to x. And that looks horribly complicated, I understand. That's something you need to memorize, and hopefully what will help you in memorizing is that du's will cancel out, so to speak. So it's still dy on dx. dy on dx. We just add a du at the bottom here, and a du at the top there. So it is something you do need to memorize, just like the way it looks, and understand what it means. I've just explained it. And when we're actually differentiating, you can think of it in simpler terms, which I'm about to show you. Here's a simpler way to think of it. If you have a function inside another function, then really you have an inside function and an outside function, right? So over here, what's inside? If you look over here, what's inside? Well, clearly, this is inside. It's inside the brackets, right? It's inside. And then you have to the power of 4, which is outside. So keep that in mind. There's an inside function and there's an outside function. And so in y equals x squared plus 3x all to the 4, you have an inside function x squared plus 3x, because it's inside the bracket, and the bracket stuff all to the power of 4, we can call that, everything of that as the outside function. Then what is the chain rule saying? The chain rule says to differentiate this, we do the following. Differentiate the outside function, leaving the inside alone. Then you multiply that by the derivative of the inside function. That's it. So you differentiate the outside function. So how, if you guys remember when you, from previous chapters, how would you differentiate this? The power comes down, we leave the inside alone, whatever it is, we decrease the power by 1. Simple. That's the power rule. And we'll multiply that by the derivative of the inside function. So what is the derivative of the inside? What is the derivative of this? If you had y is equal to x squared plus 3x, then the derivative of this would be 2x plus 3. And so we'll just multiply by 2x plus 3. And you're done. Whoa, don't know what happened there. Anyway, that's pretty much it. And obviously, what was inside, we're just going to leave it alone. So we're just going to write over here, x squared plus 3x. We don't touch it, we leave it alone. And that's it. That's the chain rule. Okay? So make sure you read this. Make sure you make sure you learn and memorize it. You differentiate the outside function, leaving the inside alone. Then you multiply by the derivative of the inside function. That's the chain rule. So let's have a look. Applying the chain rule with another example. If you had that, we could do this the old way, where you could, expand the bracket, and if you expanded the bracket, you would get that. You can just pause the video, make sure I haven't made a mistake. But yeah, if you expanded the bracket, you'd get that, and then we could, differentiate that, and you'd get 6x to the 5 minus 3 comes down, 3 times 6 is 18, x squared, and so on. And the 9 will disappear, of course. Or we can use a chain rule. And remember, the chain rule says the 2 comes down, we leave the inside alone, decrease the power by 1, and then you multiply by whatever the derivative of the inside. So 3x squared, and you're done. And so you'd get 2 times 3, which is 6, so I'll cross that out, 6x squared, x cubed minus 3. And you could expand that, and you would get the same thing. Unless I've made a horribly silly mistake. But yes, that's what you should get. And you would get the same thing. Okay, moving on. Of course, the second method seems far more cumbersome and annoying and confusing, and I'm sure you could, throw a few more swear words at it. But the thing is, there will be situations where you won't be able to expand. For example, what if, look at this question there. What if that question, instead of being squared, what if it was to the power of 20? You can't expand that. You'll be here all day. So you really need the chain rule. And that's just one example. I mean, there's countless more examples. This was a very, very, very simple example. You will get much more complicated stuff, and to differentiate it, you will need to use the chain rule. You gotta know it. If it was all to the power of 20, it'll take you all day. But if you differentiate using the chain rule, you can do it in your mind after a bit of practice. Not this year, you guys. You have to show all working out all the way till the HSC exam. You need a lot of practice, and you're gonna make silly mistakes. So show all the working out. Don't do it in your mind. Not yet. Maybe halfway through year 12, maybe, but not at the moment. Anyway, so example of complete working out. Let's see how you'd actually do this to show an examiner that you know the chain rule. How would you lay it out? Okay, so what you'd say y is equal to 2x squared plus 3 all to the power of 7. And then we recognize straight away that there's an inside function, so we say let u equal 2x squared plus 3. We're going to sub this out. We're going to sub this, and we're going to say this is u to the 7. I'm going to think of this as u to the 7. Okay, so then y is equal to u to the 7. Pretty straightforward so far. Nothing complicated, right? I've just swapped that out for u. And I've let the examiner know. So you have to use these words. Thinking mathematically, working mathematically requires that you use mathematical language. So just learn it. It takes a bit of practice. It's very straightforward. We let u equal that, then y is equal to u to the 7. And then we're going to write down the chain rule. By the chain rule, or we could just write the chain rule, whatever. The point is you have to show that you know the chain rule. And again, you'll need to have this memorized. And I did show it to you earlier. I'll show it to you again. Just notice that those will cancel out. du's will cancel out. So you still have dy on dx. So dy on dx. So the way you would write it is you'd write dy on dx is equal to, you write a dy there, you write a dx there, right? Because dy dx, and I just write du here and a du there, and you're done. Very straightforward, okay? Anyway, that's the chain rule. And now, to use the chain rule, I will need to know what this is. The derivative of y with respect to u. The derivative of y with respect to u. So we're going to differentiate that. Multiplied by the derivative of u with respect to x. U with respect to x. So we have to multiply by the derivative of that. So let's find out the derivatives first. Du on dx, u and x. I'm going to differentiate u with respect to x. So I differentiate this. Du on dx is 4x. 4x, using power rule, right? And then, that's that cancelled. That's that done. Du on dx. We're just going to sub it in. So we're going to have times 4x. What's that? Dy on du. Well, dy on du, we'll just differentiate this. Dy on du, right? 7x, 7u to the 6. 7u to the 6. So dy on dx equals to that. Okay, so it's equal to that. Now, we know what u equals to, because we let u equal to that. So I'm going to unsubstitute, so to speak. I'm going to sub it back in. So you sub it back in, and you simplify. 7 times 4 is 28x, and so on. So pause the video, make sure you understand every single step. There's a fair few steps. You got to know them. And yes, you have to show complete working out. I am not kidding. If you try to do this in your mind or you don't show the working out, I will give you 0 in year 11 and early part of year 12. Because you will make a mistake. And even if you get it right, I don't want you to be doing that. You need to be showing complete working out. Okay, so here's a check your understanding question. Pause the video and give it a go. See how you do. And come back come back in a couple of minutes and see how you did. Make sure you show the working out, okay? So this is the working out. Make sure you rewind the video and show the working out completely. So pause now. All right, I'm assuming you're back. And this is my working out. So we let y equals to that. Let u equal to that, the inside function. We let u equal to the inside bit. Then y equals to u to the 6. We differentiate these two and we write them over here. We write the chain rule. And we make the appropriate substitutions and you simplify and you're done. Yeah. So pretty much the way I did it in the previous question. That's pretty much what you do over here. Compare your working out to mine. And if you have any questions, you can ask me on Slack. One more practice question. Again, pause the video and give it a go. See how you do. And then I might do this one actually. I'll do this by hand. Okay, so pause now. Okay, I'm assuming you paused it. So y equals to 7, 3x plus 4 all to the 5. So we let u equal to the inside bit. Okay, and therefore y is equal to 7u to the 5. See, if that's the inside bit and that's u, what do we have? We have 7u to the 5. 7u to the 5. And then so du on dx, I'm going to differentiate u with respect to x, is just 3. And dy on du, we're going to differentiate y with respect to u. 5 comes down, 5 times 7 is 35. And you have u all to the power of 4. Okay, then by the chain rule, and then you write dy on dx is equal to, right, dy there, right, dx here, du. Make the substitutions. Okay, so dy on du is 35u to the 4, multiplied by du on dx. Du on dx is 3. Okay, cool. And we know what u is. So 3 times 35, 70, 105. 105. And I'm going to write u. What's u? 3x plus 4. 3x plus 4 all to the power of 4. And I'm done. And let's check if I got it right. 105, 3x plus 4 all to the power of 4. Great. All right. And as I mentioned earlier, there will be cases where you'll have to use the chain rule. You'll have no choice. And the example I gave you last time was, what if you had y is equal to something like, I don't know, 3x squared plus 3 all to the power of 20. And what if you had that? Then you have no choice but to use the chain rule. Sorry about that. Okay, so I'm back, and as I was saying, if you have y is equal to, 3x plus 5 or something all to the power of 20, you'd have no choice but to use the chain rule, because, no way are you going to sit there and expand that. That's ridiculous. But, what another example might be, for example, y is equal to same thing as before to the power of a half. You can't expand that. You can't, that's square root of 3x plus 5, right? Half means square root. And that's not something you can expand. That's not something you can differentiate. You have no choice but to use the chain rule. And so, yeah, it's not optional. You got to know it. And later on, when we learn to differentiate signings, for example, if you have y is equal to sine of x, then the derivative of this, we haven't done it yet, but that's okay. When you look back at this video and you're in year 12 and you know what you're doing, how does the chain rule apply then? Well, the derivative of this is cos x. Cool story. Okay, but what if you have something like y is equal to sine of 5x? See, it's the chain rule now. You have a function inside another function. You have 5x here. You have to use the chain rule. And so, yes, look, you got to know it. Make sure you practice it a lot. You're going to be really good at it and just be able to do it fluently without making mistakes. And so, yeah, that's an example of square root. You would have no choice but to use the chain rule here. And, yeah, so I'll go through it. It's all to the power of 0.5. 0.5 comes down, and then it decreases by 1, so it becomes negative 0.5. And then you multiply by the derivative of the inside. So examine it, make sure you understand it, and then you simplify it. As always, if you have any questions, please ask me on Slack. And best of luck with the homework. The homework is there. Best of luck.